Road Bond EN1 will maximize the benefit of conventional stabilizers, such as Portland cement and fly ash. This advantage allows one to reduce the amount of Portland cement or fly ash required to achieve the intended strength of the treated material. Reducing conventional stabilizers will save time, reduce trucking expense, and reduce airborne dust particulate at the job site. Also, the production of Portland cement consumes vast amounts of energy, water, and other natural resources, plus emits hazardous air pollutants such as CO2, mercury, arsenic, and lead. Road Bond EN1 offsets the negative environmental impact of Portland cement, reduces the carbon footprint of the project, and advances a more sustainable environment. Numerous tests clearly show a significant strength gain when Road Bond EN1 is combined with conventional stabilizers. For example, the Texas Department of Transportation conducted lab strength tests on pit-run gravel base and 4% fly ash, with and without Road Bond EN1. The result is an increase from Class 2 base with fly ash alone to Class 1 base, simply by adding Road Bond EN1 to the mix design. In a similar test, TxDOT added 2% fly ash to limestone base with and without Road Bond EN1. Road Bond EN1 increased the unconfined strength by 400%. The same test indicated that 4% fly ash plus Road Bond EN1 improved the unconfined strength by over 200%. TxDOT conducted a field test evaluating 7% fly ash with and without Road Bond EN1 on U.S. Highway 83. The contractor stabilized the reclaimed in-place material with 7% fly ash, and for comparison, a section with 7% fly ash plus Road Bond EN1. Both sections were tested 30 days after construction using the Kessler Dynamic Cone Penetrometer. The device is handheld and equipped with a 17.6-pound weight that drops 22.6 inches and strikes an anvil. These blows drive a 7/8-inch diameter cone into the ground, and the penetration depth is measured. Once the data is obtained, the number of blows delivered to the anvil and the total penetration depth are entered into a Microsoft Excel template that was developed by the U.S. Army Corps of Engineers. The template mathematically converts the raw data to CBR. At 30 days, the CBR of the control section was 142, and the CBR of the Road Bond EN1 improved section was 179. That is a 26% strength increase. 5 months later, both sections were tested again, and the difference is even more significant. At that point, the CBR of the Road Bond EN1 improved section had increased to 274, and the CBR of the fly ash section had decreased to 134. Road Bond EN1 gained 53% more strength from 30 days to 6 months, while the fly ash lost 6% strength. After 6 months, Road Bond EN1 is over 2 times stronger than the fly ash alone, and the strength had increased over time. As a further benefit, Road Bond EN1 delays the onset and reduces the magnitude of block or reflective cracking. The city of Fort Worth, Texas, reclaimed a portion of Floyd Road using Road Bond EN1 and 3% Portland cement. The remaining section of Floyd Road was rebuilt traditionally using 6% Portland cement. 8 years later, the control section has many cracks and extensive repairs, while the Road Bond EN1 improved section has very few cracks and no base failures. The city of Fort Worth then duplicated the field trials on other projects, including Earl Street. The east end of the street was rebuilt using 3% Portland cement plus Road Bond EN1, and the west end of the street was rebuilt as usual using 6% Portland cement. After 4 years, the Road Bond EN1 section has very few cracks, and the traditional section has extensive block cracks. After 8 years and extensive maintenance on the section without Road Bond EN1, the difference is even more impressive. 18 to 20 years after construction, 3 of the initial trial streets were tested for strength using the Kessler DCP. The average CBR of the 3 streets using 6% Portland cement was 210, whereas the average CBR of the 3 streets using 3% Portland cement plus Road Bond EN1 was 349. Not only did the streets require less maintenance over time, but also years after construction, the Road Bond EN1 treated streets were, on average, more than 60% stronger. Much like the city of Fort Worth, the city of Louisville, Texas, has used full-depth reclamation at 6% Portland cement to rebuild existing city streets. In 2004, this practice was modified by reducing the Portland cement to 3% and adding Road Bond EN1. After 1 year, the Road Bond EN1 sections have very few cracks. However, the cement-only sections have significant cracking, which is common for cement-treated soil. After 4 years, the cement-only sections have many cracks that have required maintenance and several areas that have failed badly. On the other hand, after 8 years, the Road Bond EN1 improved streets were still in remarkably good condition. Some cracks have occurred, but overall, the streets have required very little maintenance. 12 years after construction, the Road Bond EN1 improved streets were tested for strength with the Kessler DCP, and the average CBR strength is 229. Numerous drilling locations and lease roads have been constructed using the Road Bond EN1 advantage. For example, in the Eagle Ford Shale Formation, a series of drilling locations were tested several weeks after construction for in-place CBR using the Kessler DCP. Initially, one drilling location received the usual 8% Portland cement, and another location received 4% Portland cement plus Road Bond EN1. The 8% Portland cement location had an average CBR of 68, while the Road Bond EN1 improved location had an average CBR of 97. That is 50% less Portland cement and 43% more strength. The tests indicate that Road Bond EN1 soil stabilizer does add significant strength to the treated locations with less Portland cement. So on future locations, the amount of Portland cement was reduced from 8% to 3% plus Road Bond EN1. The average CBR of 3 locations stabilized with 8% Portland cement is 63. The average CBR of 10 locations stabilized with 3% Portland cement plus Road Bond EN1 is 78. That is 62% less Portland cement and 24% more strength. These are just a few of the many projects improved by using Road Bond EN1. Road Bond EN1 produces a significant strength gain, saves time and money during construction, and reduces truck traffic and harmful airborne dust particulate at the job site. Road Bond EN1, furthermore, conserves natural resources and promotes sustainability by reducing the need for conventional stabilizers that have a negative impact on the environment. Maximize your next project and go green with Road Bond EN1.